So we said anytime we have a system of linear equations, these are our three possible outcomes. Every time we solve any linear system, and this will be true even when we start adding more letters and more equations to the mix, we're either going to find out that there's no solution to that system, there's one solution to the system, or there's an infinite number of solutions for that system. Again, there's no way to create a linear system of equations that has exactly 3 solutions or exactly 12 solutions. So we're going to look at this system that we started class with, started in the first video, and we're going to talk about an algebraic way to solve that system of equations. We said graphing is one way we can approach it, but it's not going to be the best way because especially if our solutions aren't nice integer values or even rational values, we can't look with our eyes and see what's going on. So the first method we're going to talk about today is we're going to talk about the method of substitution in this video. When we use the method of substitution, the first thing that we're going to do is we're going to choose an equation and we're going to solve for one of the variables. Okay, now when we say we're going to solve for one of the variables, that doesn't mean that we're going to go straight to x equals 9 or to y equals 3. Okay. What that means is we're just going to rearrange the equation that we're given. So it says x equals stuff with y's or y equals stuff with x's. Now we're going to pretend like in the last video we didn't solve both of these for y already. So in this example, I'm going to start by solving the bottom equation for x. If I'm going to solve the bottom equation for x, then all I have to do is subtract 4y from each side, and I have x by itself. Anytime you have a 1 or a negative 1 as a coefficient, when you're using substitution, you're going to focus in on that variable and say, hey, that's where I want to start. So the next step in substitution is not to do that. This is where the name comes from. We're going to substitute that expression into the other equation for that variable. Meaning, I'm going to pick up x equals negative 4y minus 1. I'm not going to go to the equation that I started with. Oop, can't do that. I'm going to go up here to the other equation, and in place of the x, I'm going to put that stuff in the circle. So instead of 2x minus y equals 7, in place of the x, I'm going to put negative 4y minus 1. Now think for a moment how that helped us. Look at what we have there in that line. What we have now is one equation, and it's a linear equation, and there's only one variable in it, meaning now it only has y's. So I can take that equation now and I can solve it for y and I can get a number. Okay, the next step is that I'm going to solve for the remaining variable. I'm going to put I guess I'm going to put the steps super fast. We distribute, we combine our like terms, we keep the x's on one side, or y's in this case, add the 2 to the other side, and divide everything by negative 9. Now realize that once I have my y, I'm not done. Some students will just circle the answer and go on to the next problem. Remember that what we're trying to find here is the ordered pair solution for that system of equations. Meaning, now that I know the y, I need to find the x that goes along with it. So we're going to go back now to either original equation and substitute our value in and solve for the other variable. Not a super great sentence there, but we're going to take this negative 1. We're going to come back either to the top equation or the bottom one, we're going to plug it in for y, and then we're going to solve for x. So maybe I pick the top one just because that's the one my eyes saw first. It says 2x plus 1 equals 7. I'm going to go bottom to top here. So 2x equals 6. So x equals 3. Now once we have our y and we have our x and we found them in either order, it varies problem by problem. Okay, we're not completely done. The last step is a cosmetic step, but it's still a required step if you want full credit on your homework quiz or test. Okay, once I know what the x, the x and y values are, we're going to write the solutions. I'm going to write it as though sometimes there's more than one. We're going to write them as ordered pairs. Okay. Now, if there's more than one, there will be an infinite number of them, and we'll get to that in another video. But what I'm actually going to circle on my paper is the ordered pair solution. So even though I found the y first, I have to put it in the second position there because it always goes x and then y. Okay, here's the solution to that system of equations. Now, recall when we graphed them, that's the solution we found. And we really kind of cheated because we started the hour with, hey, is this a solution for that system? And it turns out it was. And so now we've shown algebraically why it is. Okay. When we use substitution, we start by solving one of the equations for one of the variables, either x equals stuff with y's or y equals stuff with x's. We plug that into the other equation, and it's very important that you go to the other equation and you plug it in place of the x, we put in that circled stuff. That gives us one equation with one variable. Now we can solve and get a numerical answer. Putting the -1 back into one of these two up at the top, it doesn't matter if we plugged it into the bottom, we would also find out that x equals 3. Don't forget to write your solution as an ordered pair when you're done. Okay, we're going to turn the page here and do another example. Okay, so here is our new system that we're going to work with. And the one thing I didn't say on the other page is when we're starting with substitution, we get to choose our equation. We get to choose the variable, which means there are 4 correct places that we could start on every problem of this size. I could solve the top equation for x or for y, the bottom one for x or for y. Now again, if I see a 1 or a -1 in front of one of my coefficients, that's what I'm going to focus on. And so I'm going to say, hey, it's going to be shortest for me and easiest because there will be no fractions involved if I solve the top equation for y. Go ahead and pause the video. Start by solving the top equation for y if you want your steps to look like mine. Okay, and take it as far as you can, and I'll turn back on with checkpoints along the way, so you can start and stop the video as you need. If you solve the top equation for y, you get y equals -3x minus 7. You're going to then put that expression into the bottom equation in place of the y, and now you have an equation with only x's. So we'll solve that for x, take the number we get for x, plug it back into the top, and find the y. Go ahead and pause the video and keep going if you were stuck here. Solving that equation for x gives us x equals -4. We take the -4 back here into either original equation, then we can find the y that goes with it and write our solution as an ordered pair. I plugged it into both equations just so you can see that it doesn't matter which one we pick. As long as our -4 is correct, we will get 5 out for y from either one. We're going to write our solution set then as an ordered pair, -4, 5. If we were to look at the graphs of these two lines, we would find out that they intersect at this point right here. Okay, so there's substitution. The next video is going to have the other method on it, and then we'll have some of the special cases, and then we'll have a video where there's just some extra practice for you, assuming I have time to get through all of those.